Today we're going to take a look at section 6.5, and we're going to start going through properties of logarithms. And there are 4 properties that we're going to go through. And we're going to start with the first 3. And I'm going to go through the properties and I'll explain why we need to know them, and then we'll go through some examples of how to use them. Okay, so the 3 properties are the product, the quotient, and the power. So the product property says log b of mn is equivalent to log base b of m plus log base b of n. Quotient property, log base b of m divided by n is equivalent to log base b of m minus log base b of n. And then the power property, log base b of m to the power of n is the same thing as n times log base b of m. Okay, so we'll go through some problems here. I know that's very abstract, but those are just the definitions of each of the properties. And the reason we go through these 3 properties is in the next section, when we actually get to solving equations using logs, you have to know how to use these properties for certain equations to get them to a situation that allows you to solve them. So, eventually we'll get to the equations and we'll go back and we'll look at some more exponential modeling or other problems that are modeled by logarithm equations. And you just have to be familiar with these properties. Okay, these are related to the exponent properties. They should seem a little bit familiar in that sense, but otherwise they're going to be a little bit new. Okay, so let's just go through some examples. And what we're going to do, well, let me give you the first problem. Okay, so what we're going to do for number 1 is we're going to do what's called expand this logarithm, which means we're going to make it as big as we can, break it apart as much as we can. And so we're just going to use the properties. Now, as we do that, the log has 5, and then every time we write log, it's going to be base 5 for this problem. Okay? And so what we're going to do is, when we expand it, and I usually like to do it in one step. I think it's easier in the long run if you learn how to do that, but you can break it down if you need to. So I'm going to start with log base 4. Now I'm multiplying by the x, and that means I'm going to write that as plus 7 times log base 5 of x, and then the minus log base 5 of y. So if you think about that, we start with the exponent here. Everything in a fraction. Everything in the numerator, when we expand it, is a positive term. Everything in the denominator is a negative term. And then when we multiply those 2 things, that becomes addition. And we also had a power, so the power comes out to be in front. Okay? So let's try another one. And once you try, see if you can do this one on your own. So after I write it down, yeah, I lost my place. There we go. Okay, this one's a little bit shorter than number 1. Okay, so go ahead and pause it and try this one. Okay, so when we expand it, it's going to become log base 6 of 3 plus 4 times log base 6 of x. And that's as much as it can be expanded. Okay, one more. Let me go to the next sheet. Okay, go ahead and try that one. Alright, so when we expand this one, the 5 is the only thing in the numerator, so it's going to have a positive term. So that means it's going to be positive log base 2 of 5. Now I have 2 things in the denominator, okay, and because both of these things are in the denominator, then both of them are going to be negative. So it's going to be minus log base 2 of 12, and then also minus log base 2 of x. Okay? And that's their final answer. Now, in a problem like this, sometimes people get confused because they say, well, the denominator is really 12 times x, so why is it not plus? Well, here's another way that you could do this problem, and hopefully that kind of answers your question if you have that question. We could also do it as log base 2 of 5 minus, and then in parentheses, I could just do the denominator. So if I were to just expand the denominator, I'm looking at just the 12x, then I'd have log base 2 of 12 plus log base 2 of x. Well, if I do it that way with the parentheses, after you distribute the negative sign, then you get what I did when I first wrote it up there. It's just different ways of looking at the problem. The main thing to understand is that every time you have something in the denominator, either a number or a variable, it's going to be a subtraction because you're dividing by that. Okay, the other thing we're going to go through using these properties is condensing. So the next problem . Okay, so when we condense on number 4, that's just working backwards. And so what we're going to do is we're going to combine it so that it's all, and I forgot to write log, that should be log of 9. It should just be one log when we finally write our answer. Okay? Now, just like we talked about up here with this one, if the term is positive, then it's going to be in the numerator of the fraction. If the term is negative, it's going to be in the denominator. So I'm going to have log of 9 will go in the numerator, and then times, also in the numerator, this is going to become 2 to the power of 3, and then the subtraction is going to go in the denominator. So that's initially how we're going to set this up. And then what you would go ahead and do with this problem is go ahead and work this out as much as you can. So 2 to the power of 3 is 8, 8 times 9 is 72. 72 divided by 3 is 24. So your final answer here would be log of 24. Okay. Now, of course, if you had a variable, you wouldn't be able to simplify it all the way to just one exponent. Okay, let's go ahead and try number 5. Go ahead and pause it and see if you can do that one. Okay, when we look at the answer, as we set it up, it's going to become log base 4 of, and then this term is positive, so x goes in the numerator. This term's negative, so 9 goes in the denominator, and then y is positive, so that goes in the numerator as well. And that's as much as you do. We can't simplify what's in there, so that's our final answer for number 5. Okay, one more. Okay, go ahead and try that one. Okay, so our answer here, in this case we all have all numbers, so I'm just going to set it up and then we'll simplify as much as we can. So it's going to become log base 3 of 4, and then this is positive, so times 3 to the power of 3, and then 12 in the denominator. So 3 cubed is 27. 27 times 4 is 108. And then 108 divided by 12 is, I think that's 11. So log base 3 of 11.